Now, obviously, we need to also invert the colors of the ground and the obstacles, also of the high score, actually the scoreboard, and also the game over screen. Okay, so between cuts, I just went ahead and took another look at the original game, and actually it appears to me that that everything is inverted. It's not just exclusive to the obstacles, the ground, and the T-Rex, as well as the game over screen and the scoreboard. The sky objects are actually, like the moon, the stars, and the clouds, are actually also inverted. It didn't look like it at first, but they're actually inverted as well. So that means that everything is inverted in color, not just some of the entities. And you can tell, well, basically I could prove that if I take a screenshot of this, paste it here, copy the color of the moon, and paste it into our texture here, you can see that it's actually almost black. And yeah, earlier we took a look at how the moon looks when it's inverted, and it does actually match this color. So yeah, I think we don't need to differentiate between entities that need their graphics inverted and entities that don't, because all of them are actually inverted. So I guess we could make some optimization and actually accelerate this process of inverting the colors. So this stays. Obviously, we still need to invert the texture, but what we don't really need is this new interface that we created, the iTexture invertible interface. Let me go ahead and delete this interface. Yep, okay. So now the compiler will obviously complain here. Obviously here, this interface no longer exists, so let us just remove it. And that also means that we no longer need to implement it here. That means we can remove the update texture method from the T-Rex class. So that's what I'm gonna do. There. And here in the Sky Manager, obviously this doesn't work anymore either, but we don't actually need it. So let me go ahead and remove this. But it does make sense to have this method here. It just needs to be implemented in a different way. Basically what we need to do is just invert the colors of the texture. We already did that. We have two different textures here in our Sky Manager. The sprite sheet and the inverted sprite sheet. And basically what we just need to do is swap the texture data, which is the pixels, in those textures whenever we want to invert the colors. So what I'm going to do is I'm going to add a new field of type color array. And I'm going to call it texture data, and another one named inverted texture data. And then I'm going to initialize these two fields in the constructor. Oh, I'm going to need to do this. There. Going to get the data of the sprite sheet and store it in this new texture data field. And then I'm going to go ahead and do the same thing for the inverted sprite sheet. And here pass the inverted texture data field. And I guess technically we don't need this inverted sprite sheet field anymore, but I'm just going to keep it. It's not going to do any harm. So yeah, and now in our invert textures method, we can simply swap the data. So I guess we don't, do we? So basically, I guess we could just go here. I guess we can remove this. Yeah, we can remove the parameter. So let me remove it here in the calls as well. And then simply all we need to do, let me just check something. Okay, let's go back into the invert textures method. And here what we could do is say if is night sprite sheet set data, and we'll set the data of the actual sprite sheet to the inverted texture data. And if it's not night, we're going to set it to the original data, which is texture data. There. And this should already do the trick. I mean, I wasn't really in favor of doing it like this originally, because I thought that, well, maybe there are some entities that don't want their texture to be inverted. But it seems like that's not the case, so why make it overly complicated? We can just actually manipulate the actual texture that all of the entities use and just implement it this way. So this will now affect every entity in the game that uses this texture. So let's try this. Value cannot be null. Okay, for some reason it's null. Oh yeah, obviously. When we want to set this, we need to actually initialize the texture data field first. So we need to do this, texture data equals new array of colors. And the size will be the sprite sheet width multiplied by the sprite sheet's height. And I just need to stop running the game and do the same thing for the inverted texture data. Technically this would work since they're both the same size, but I'm just going to change this, oops, to the inverted sprite sheet here. There. So we obviously we can't pass null here because the getData method actually manipulates the array that we pass to it. So we need to actually properly initialize it first, and we achieve that like this. So now this should do the job, and we should actually be already done with the day-night cycle stuff and inverting the sprites. So let's see if this works out. And we're slowly approaching 700 points. Yes, it works. Everything is inverted. And it's inverted back to its original state. Alright, so there's just one minor thing that still bothers me about the transition. And that is that the inversion of the texture is really obvious. It happens very abruptly, so it is really noticeable. And the original game doesn't have that problem. And I took a look at it at the original game again, and I figured out that the reason why the original game doesn't have the problem is that they very briefly, for a split second, they make the entire screen gray, so that you don't notice the change of the texture colors as much. So it's less obvious. And I figured we should do the same thing. So let me just pull up photo filter here. What I figured we could do is this. So if we hold on, let me go into the Sky Manager class. And remember, we have this field here named normalized screen color, which goes from 0 to 1. And it basically describes the brightness of the background color, 1 being white and 0 being black. And I figured what we could do, well, if this is our, if you imagine this is the, what was it called? Normalized screen color variable or field. And this was the value 0, and this is value 1. And here we have the value 0.5, obviously. And this is where the transition happens. Just maybe use a text tool. Or let's say inversion. There. So at 0.5, it doesn't matter if we go from 0 to 1 or from 1 to 0. At around 0.5 is where the texture is inverted. And yeah, since the screen doesn't currently turn gray for a moment, this inversion is noticeable to the player, or it's very, very sudden. And what I figured we could do is we could say that from this point in time here, maybe let me use another color, say here, this being 0.25 and this being 0.75. Let me show my art skills again here. During the transition, in this time frame here, we need to also change the transparency of a gray overlay over the entire screen. So we can basically hide the entire game screen for a brief moment. So at this point here, during this time window, this gray overlay would not be visible at all. So it would have the value 0. And then when it moves from here to here, it would have this value 1. And the same in the other direction. So as soon as we, in the transition, as soon as we reach 0.25, we would slowly increase the visibility of the gray overlay towards the value 1, and then decrease it again as we move towards 0.75 in the transition timeline, basically. So really what we want to accomplish here is we need some new value. So we are going to define a new field. We can call that maybe overlay visibility or something. 0 meaning it's not visible at all, 1 meaning it's entirely visible. So it's the transparency. And we can easily calculate that. Basically, we need to check the distance between its current value to 0.5 and then divide that by 0.25. Because that is the entire difference here. The entire difference between those two values. So I guess we can just introduce a new property that calculates that value for us. So we don't actually need a field to store the visibility value. And let me just show you what I mean. It's actually going to be fairly simple. I'm I'm going to go here in the Sky Manager class, and I'm going to add a new property. And it doesn't need to be accessible from outside, so it's going to be private. It's going to be of type float, not float. And let's say overlay transparency. And that would be, like I said, we need to calculate the difference between 0.5 and its current and the current value of the normalized screen color here, which would basically indicate the progress in the transition animation, and then divide that by 0.25, and getting the distance between the current value of the normalized screen color here and 0.5 basically just means the absolute value. But MonoGame actually provides a math helper class that has a method named distance, and really all it does, it gives us the difference between two values and the absolute value of that. So here we could say 0.5 and the current value of normalized screen color. So if normalized screen color was, let's say 0.75, this would give us 0.25. Yeah. But I think, well, first of all, we need to divide this by 0.25. But we also need to, since it should be the progress, I guess we should also say this, right? This should give us the correct value. Right. This should be correct, right? So let's say, let's go back here. Let's say it's here. So basically 0.3. If we then take 0.25, that's what we said, 0.3. So that would give us, distance would return 0.2. So this would, yeah, this subtraction would return 0.05. Then we divide that by 0.25. Yeah, that seems okay, correct. And also we want to make sure that the value never exceeds 1, and also it should never be lower than 0, obviously. So yeah, there's another helper method in the MonoGame framework that we can use for that. It's also in the math helper class, and it's called clamp. So we pass a value, and we pass the two values that we want to constrain it within. So 0 and 1. And also I just noticed that we need a pair of parentheses here. There, otherwise we're going to get the wrong result. And this should be okay. If you want, you can also not use an expression body and just use a regular getter syntax like this. And semantically, it's absolutely the same. Okay, I think it should be all right. But maybe we should subtract this value from 1, since it's the transparency and not the visibility. Does that make sense? So let's say the normalized screen color is at 0.25. That would mean the distance would also be 0.25, making this value here 0. And if we divide that obviously by 0.25 would give us 0 as well. So that would mean a transparency of 0. That doesn't sound right. So I guess we should say 1 minus the value. Or we can rename it visibility. I don't know. I guess we can go with this. Okay, now we need an actual gray overlay. And for that, we can just simply use a 1x1 texture. So let's maybe go up here, say private texture 2D, overlay. And in the constructor, let's initialize that field. There, graphics device. For the graphics device, we can simply pass the same graphics device as used by the sprite sheet. Width is 1, height will also be 1. There we go. And now we need to set the data of that texture to simply a gray pixel. And we can achieve that by, first of all, initializing a color array. And even though there's just one color instance in there, it's going to be an array. So let's say overlay data. Oops. And there should be a predefined color, gray. And yeah, that seems fair. And now we can just simply call the setData method of the texture and pass the overlay data here. And technically, I guess we could omit this part here. Yep. Oh, there. We don't need to specify the type since it can be derived from the type of the elements. But yeah. Okay. That should be fine. And now we should render this texture in the draw method, I guess. Let's say overlay, whoops, no. Sprite batch, draw. Oh, right, we need, there's just one thing. We need to make sure that the overlay is drawn on top of everything else. But luckily, we can just use the draw order property for that. Currently, it's at 0. And if it's on top of everything else, that means the value must be very high. So let's just use the maximum value of integer. That seems drastic, but it'll make sure it's always on top. Okay, now past the overlay here. The destination rectangle will be a new instance of rectangle with the start position being 0, 0 and the width being the entire screen. And the height also height of the screen there. I mean, if we just pass white as the tint color, it's going to be fully visible. But we need to make sure that it's transparent according to the current value of the transparent overlay transparency property. And let's see. And I think a simple way to achieve that is simply here you can see the white, the predefined white color obviously has an alpha of 255, meaning fully visible. And I think the multiplication operator of the color struct is overloaded so that it actually influences or resets or returns a new color where the alpha channel is recalculated. So maybe let's go. Should work, right? This should return a new color. Yes, it does. So this was 0. The alpha would then also be 0, which would make it invisible. Wait, then do we actually need to... Let me check this again here. If we go here, say the value is 0.25. That would give us 0. Yeah, maybe, I mean, subtracting the value from 1 would actually be correct if we use the terminology transparency. But I'm going to remove that, and I'm just going to simply rename this overlay visibility. I don't know. Something like that. Or, wait, did I just mess this up? If we here at 0.25, the value that this would return 0. But that's not correct. Because then, the draw method, the alpha would also be 0. Oh no, that's right. Which makes it invisible. And then it, yeah, okay, no, that should be okay. Okay, sorry, I was confused for a second. Yeah, that should be all right. And I think that's it. But just to be sure, I don't want this draw method to always be called. It should only be called if it's relevant. So basically, if the overlay visibility is greater than, I don't know, 0.001 or something, this should be okay. So if the visibility value is less than this, then it doesn't actually make a difference. So we don't need to call the draw method. So let's maybe, I don't know if there's already some sort of epsilon. Nope. Maybe let's just say, let's go up here and say epsilon there, and to find a constant value named epsilon, and then we're going to compare the visibility to that value. So only if the overlay visibility property returns a value that is greater than epsilon, which is a very small value, then we want to draw the overlay texture by simply calling the draw method of the sprite batch. And that should be fine. Let me check if that works. Okay, we're almost there. Here we go. And there you go. It looks great. So now the color swap is no longer that obvious. And as you saw, it also works in the other direction, basically, when it turns back to daytime. And now it should turn back to nighttime. There. And due to the gray overlay, the texture inversion is not that abrupt and obvious. Great, perfect. Okay, the next thing I want to focus on is a little optimization, or maybe you could call it a bug fix. Because in the original game, and I didn't realize that before, when you reach a score, or whenever you reach 100 points, and the scoreboard blinks for a second, it actually freezes the score value. So it will no longer update the score value during the blink animation, but instead it will just show 100 or 200 or 300, whatever score it was that you reached. So if you take another look at our implementation here, when we reach 100 points, if I can make this jump, okay, great. The scoreboard does blink, but the score just keeps updating, which one could say is an improvement to the original game. It's just different than it is in the original game, but we want to, keep it faithful to the original. So whenever we reach a score divisible by 100, we want to actually freeze that displayed score value for a moment while the animation is playing. Obviously, you still get points, so you just don't see it. So let's go into the scoreboard class here, and let's see how we can achieve that. And here in the draw method, we're currently checking if the flash animation is not playing or it is not an even frame within the blink animation. Then the score value should be drawn, and that's fine. We can leave it like that. But I guess we will have to make a little enhancement here. First of all, let me add the braces to the if block simply by selecting the if statement here, then say add braces. There we go. This makes it a little easier for us to change this. And I guess it's fairly simple. We could do int. Let's call it score. And then say is playing flash animation, or maybe if it's not playing the flash animation, then simply show the display score, but otherwise show the display score rounded down to the next 100. Yeah, so that would mean the display score divided by 100, and remember this is an integer, so this is an integer division, and then we just multiply it by 100 again. Simple as that. Let me put that in parentheses here because this is one expression. This should be okay, right? And then we just simply pass the value here instead of directly passing the display score property. So now if the flash animation is not playing, we just simply render the display score as we usually do. But if that is not the case, then we divide the display score by 100 using an integer division. And then we multiply that by 100 again. So let's say the display score is 1,713. So 1,713 divided by 100 as an integer division would give us 17. And if we then multiply that by 100 again, it would give us 1,700 or 1,700. So it's rounded down to the next 100, or to the next value divisible by 100, and then we pass that here to the draw score method, and this should already fix the problem, if it was a problem to begin with. I guess it's just some sort of visual enhancement. Let me test this. Yep. And as you can see, the score still keeps ranking up. It's just visually it stops updating.